Hello and welcome to Sir Optics Academy. In today's video, we'll be looking at a topic known as hydrocarbons. Now, if you are a beginner in the study of organic chemistry, then this video is made specifically for you because you understanding organic chemistry vividly has to do with your knowledge of hydrocarbons. Now, what are hydrocarbons? Hydrocarbons are organic compounds that contains hydrogen and carbon atoms as the only elements. Now, hydrocarbons, as the name implies, hydrocarbons, compounds that contain only hydrogen and carbon as the only elements. Hydrocarbons occur naturally in natural gases, in coal and in petroleum. Now note that the main component of natural gas is methane, which results from anaerobic reaction of inorganic matter in the earth's crust. Now, hydrocarbons are divided into two. Hydrocarbons are divided into two. We have the aliphatic and we also have the aromatic hydrocarbons. Aliphatic and aromatic hydrocarbons. Aliphatic hydrocarbons are those hydrocarbons that contains carbon-carbon straight chain, carbon-carbon branch chain, or carbon-carbon ring chain. Now, as a result of this, the straight chain, the branch chain, and the ring chain, aliphatic hydrocarbons, as a result of that, is divided into two. We have the acyclic and we also have the cyclic hydrocarbons, cyclic aliphatic hydrocarbons. Now, apart from being acyclic or cyclic, now first of all, let me explain this. Now, those hydrocarbons that are said to be acyclic are the ones that have a straight chain or they have a branch chain, a straight chain or a branch chain. Now, those that have a cyclic structure are the ones that are said to be ring in structures. Now, like we defined aliphatic hydrocarbons, we said they are those hydrocarbons that contain carbon-carbon straight chain, branch chain, or ring chain. Now, for those hydrocarbons that contains carbon-carbon straight chain or branch chain are referred to as the acyclic aliphatic hydrocarbons, while those that contains the ring chain are referred to as the cyclic aliphatic hydrocarbon. Now, a cyclic or acyclic hydrocarbon can be saturated or non-saturated. Organic compounds that have carbon-carbon single bond throughout are said to be saturated, while those that have carbon-carbon multiple bonds. By multiple bonds, I mean it could be a double bond or a triple bond. So for those that have a double bond or a triple bond in a carbon-carbon linkage are said to be unsaturated. Now, for those that have carbon-carbon single bond throughout the entire compound, they are called alkanes. Alkanes. Now, let's say a cyclic compound can be saturated or it can be unsaturated. Now, when an aliphatic acyclic hydrocarbon is saturated, it has carbon-carbon single bond throughout the entire compound. A very good example of saturated hydrocarbon is alkanes. While for those that have multiple bonds, example, a double bond or a triple bond, are said to be unsaturated. Example, we have alkenes and alkynes. So for those that contains a cyclic structure, they can also be saturated or unsaturated. Now for those that are saturated, for those that have, for the cyclic, for those that are saturated, we have cycloalkane. Now, for those that are unsaturated, a very good example is cycloalkene. So this is how you classify hydrocarbons based on aliphatic. Now, for the aliphatic, let me emphasize on it again. For the aliphatic hydrocarbons, they contain a carbon-carbon straight chain, a carbon-carbon branch chain, or a carbon-carbon ring chain. Now, for the aromatic hydrocarbons, they have a cyclic structure. All aromatic compounds are cyclic in nature and they are highly unsaturated. So apart from aliphatic being acyclic and cyclic, aromatic are only cyclic in nature and they are highly unsaturated, meaning that they contain multiple bonds in their carbon-carbon structures. Now, a very good example of aromatic compound is benzene. Others include naphthalene and anthracene. Now, let's try to draw the structure of benzene, naphthalene, and anthracene. Now, notice that this is the structure of benzene, while this is the structure of naphthalene, and then lastly, this is the structure of anthracene. Now, you can notice that these three structures on the board are all cyclic. They have a ring structure, and then they have, for benzene, it has alternating double bond. So what makes aromatic compound highly unsaturated is because of their multiple double bonds. It is because of their multiple double bonds. Now, look at the structure of benzene. It has double bond in 3 places. If you try to look at the structure of naphthalene, it also has double bond in many places. So, what makes them highly unsaturated? It is as a result of their multiple covalent bonds. Now, in summary, aliphatic hydrocarbons can be cyclic or acyclic. Now, the common examples of aliphatic hydrocarbons, like we said, we have alkanes, alkenes, and lastly, we have alkynes. Now, these three are the common examples of aliphatic hydrocarbon, while for aromatic hydrocarbons, we have benzene, naphthalene, and atrazine. So, with all this being said, we'll end the class here. Now, in the course, as we proceed with the tutorial lessons in subsequent times, we will upload videos on alkanes, alkenes, and alkynes. Now, if you have not followed this channel, please do well to subscribe and share this video with your friends, as they might also find it helpful. Now, this is all for hydrocarbons. Thank you so much for watching.